Hi, in this video we're going to be talking about complex numbers in rectangular form. To represent a complex number in rectangular form, we would write it as z, the complex number, equals a plus bi, where a is the real part of the complex number, b is the imaginary part, and I is the imaginary unit, which is the square root of -1. If I wanted to represent that complex number graphically, I would need to express it in the complex plane. So we'll have the real axis where the x-axis would have been and an imaginary axis where the y-axis would have been. And then I would just say, let's make that an A and that a B. So our complex number, A plus BI, would be right here on the complex plane. Now, if you're studying electrical engineering, this A plus BI form, you might see more frequently, you would say Z equals A plus JB. So J is the imaginary unit, square root of -1. It's used instead of I in electrical engineering, often because current is represented by the letter I. So if you're studying electrical engineering, just remember you might see a slightly different form. It's still rectangular form, A plus JB. Okay, so let's plot a couple complex numbers on the complex plane. So I've got Z1 equals 3 plus I. So on the real axis, I've got 3 units over, and then my B is 1, right? The coefficient of I is 1, so that's my B. So right here is my complex number Z1. What about Z2? Well, A is 2, so that's my real part. And my B is -5. So Z2 is going to be represented by that dot right there, Z2. Okay. All right. So what we're going to do next is we're going to do operations. We're going to on complex numbers in rectangular form. We're going to do addition, subtraction, multiplication, and division. So if we wanted to add two complex numbers, Z1 and Z2, what do? Well, let's start it up here. So Z1 plus Z2 is 3 plus I, and I want to add to that 2 minus 5I. So all we're going to do here is we're going to add the real parts together, and we're going to add the imaginary parts together. Actually, the way I think about it is just pretend I is a variable. It's not, but pretend it is. And then what are you going to do? You're going to combine like terms. So we'll say 3 plus 2, those are like terms. And I minus 5I, those are like terms. So we're adding the real parts and we're adding the imaginary parts. So that leaves me with 5 minus 4I. And that's the result. And you'll notice it's in the form A plus BI. Okay, so 5 minus 4I. Okay, what about subtraction? Same idea. So Z1 minus Z2 is 3 plus I for the Z1 minus, then make sure to put your Z2 in parentheses so that you can distribute the negative sign across the whole complex number. So 2 minus 5I, make sure is in parentheses. So now let's get rid of the parentheses. Okay, and so again, think of it as combining like terms. So 3 minus 2 is 1, and then I plus 5I is just 6I. So that's our result. And again, in the form A plus BI. All right, let's talk about multiplication. So if I want to multiply these same two complex numbers, 3 plus I times 2 minus 5I, it looks pretty much like we're multiplying two binomials together, right? And that's how we're going to do it. So we're going to distribute the 3 across the second group. We'll distribute the I across the second group. So what do we get? 3 times 2 is 6. And then 3 times negative 5I is negative 15I. I times 2 is plus 2I. I times negative 5I is negative 5I squared. Okay, so this is where things get a little bit different. Remember I said I isn't a variable, even though we're treating it almost like it is. It's not. So here's where that difference shows up. So I squared is just I times I, but remember what I is. I is the square root of negative 1. So what we're really doing here is we're multiplying the square root of negative 1 by the square root of negative 1, which gives us negative 1. So what we're going to do is we're going to replace that I squared with negative 1. So I've got 6, and then I can go ahead and combine my like terms here. So negative 15I plus 2I is negative 13I. And then instead of writing negative 5I squared, I'm going to write negative 5 times negative 1. Actually, I'm not going to write it because negative 5 times negative 1 is a positive 5. So I'll write it as a positive 5. So now at this point, I can combine the 6 and the 5 to get 11. So 11 minus 13I. So that's multiplication. So a lot like foiling a binomial or multiplying out a binomial, but you don't leave the I squared floating around. I squared can be simplified to negative 1. Once you do that, that negative 5I squared becomes a real number that can be combined with the 6. So again, our answer is in the form of A plus BI. Okay, before we get to division, let's talk about the concept of conjugates. So you probably saw conjugates when you were rationalizing denominators, and this is the same concept, but now it's associated with complex numbers. So because of that, we call them complex conjugates. So the complex conjugate of the complex number A plus BI, we just change the sign. So it's A minus BI. The complex conjugate, if I had A minus BI, again, we just change the sign. It's A plus BI. So let's look at what one of the characteristics of a complex conjugate is. So if we multiply a complex number by its conjugate, you can see what we've got going on here. We've got the same terms in each one of these parentheses with a different sign connecting them. So we know what's going to happen here. Our middle terms are going to cancel out. But let's go ahead and just prove it to ourselves and see what else we end up with. So A times A is A squared. A times negative BI is minus ABI. Then I've got BI times A. So I'm going to write that as plus ABI. And then BI times negative BI, so that's going to be minus BI quantity squared. So as we knew was going to happen, the ABIs zero out, and that leaves us with an A squared minus, And I'm going to go ahead and distribute the exponent. So I've got b squared times a squared. But remember what happens here. That a squared I'm going to replace with a -1. So I've got a squared minus b squared times -1, or I'm just going to go ahead and write it as a squared plus b squared. So let's think about this a little bit. So what happened? I multiplied two complex numbers together, but because they were conjugates of each other, I ended up with a purely real number. There's no imaginary part to the result. Okay. Now, we're going to make use of this concept when we go to do division. So if I want to divide two complex numbers in rectangular form, I want to divide them. So z1 over z2 equals 3 plus I over 2 minus 5I. What I want to do is I'd like that denominator to turn into a real number, because then I've got a complex number that I can write in the form of a plus bi. Because remember, that's what I want. I want a result that I can write as a single complex number, a plus bi. So how am I going to get to that? Well, if I multiply that denominator by its conjugate, what's going to happen? I'm going to end up with a real number in the denominator. All right, so can I just do that? No, because then I've changed the value of this. I have to multiply the numerator by the same thing, because what am I doing? All I'm doing is I'm multiplying my 3 plus I over 2 minus 5I by 1. So I'm not changing anything except for the form. So let's clean this up a little bit. I'm multiplying fractions. So I multiply the numerators and I multiply the denominators. So what happens now? So in the numerator, I get 3 times 2 is 6, plus 15I, plus 2I, plus, actually, let's save ourselves a step. We know what's going to happen. I times 5I is 5I squared. I squared is going to be replaced by a -1. So I'm just going to go ahead and directly write down -5. All right, let's talk about the denominator. So we know that these middle terms are going to cancel out. So I've got 2 times 2 is 4, minus, and then I've got 5I squared. So in the numerator, 6 minus 5 is 1, and 15I plus 2I is 17I. And then in the denominator, what's going on? Well, I've got 4, so 5 squared is 25, I squared is -1, so I've got 4 plus 25. So I've got 1 plus 17I over 29. So remember I kept saying for when we were doing addition, subtraction, multiplication, and now division, we want our answer to be in the form a plus bi. Well, that's not quite there yet. So all I have to do to get it in that form is to break up the fraction. So I'm just going to rewrite my fraction as 1 over 29 plus 17 over 29i. And there we go, a plus bi. And now we've completed all 4 operations.